Dear students and participants of the course on railway engineering, today we are going to continue with the rail failures. In the previous lecture, we talked about the various causes due to which the various rail failures can occur. In today's lecture, we will be discussing about the classification of the rail failures, the various types, the metallurgical investigations which are required to be done under certain specific rail failure conditions, what actions can be taken, and what are the precautions which should be taken if there is a track and the rails are supposed to get fractured. So, starting with the classification of the rail failures. The classification of rail failure is basically defined by using a code, and this code has two portions. The first portion, it consists of 3 code letters, and the second portion it may have 3 or 4 digit codes. So, this total comprises of the overall classification of the rail failure, and that will give you a complete information regarding why that rail failure has happened, where it has happened, what type of severity it has, all those information is going to be there. So, if you look at the first portion of the code, which is a 3 code letter, in this the type of the rail being used is being defined by the first letter, and we use the O for plain rail and X for the points and crossing rails. So, it defines that whether it is happening on the points and crossings or it is happening on the normal rail section. So, O and X are being used. The another one is the reason for withdrawal of the rail. So, what has happened due to which the rail has been taken out, it has been removed. So, it can be fractured defined by F, it can be cracked defined by C, and it can be defective defined by D. So, any of these 3 can be a part. So, it can be OF, OC, OD, or it can be XF, XC and XD. And the third one defines the probable cause of the failure, and this cause can be because of the rolling stock. So, if it is due to rolling stock, then S will be used. If there is excessive corrosion, then C will be used. If there is a derailment of the train and due to which the rails have fractured, then D will be used, and if none of these 3 is a possibility, something else has happened, then O is used as others. That means we can have a code like O, F, S that will define that it has happened in the plain rail section and it is a fractured condition due to the rolling stock. So, likewise different such codes can be created, and they will be defining or giving you the complete information regarding what type of failure has occurred. The another portion which can have 3 digits or 4 digits. So, this second portion, the first digit is basically the location of the fracture on the length of the rail, where it has occurred. So, that location is going to be defined. If it is within the fish plates, then 1 is used. If it is another portion of the rail, then 2 is used. That means you are going beyond the fish plates. So, a rail section is provided and there is a fish plate being jointed here. So, anything happening up to this point, then it is 1, and anything happening beyond this point is 2. Then second digit is for the position in the rail section. So, the failure which is occurring, whether the failure is occurring in the rail head or the foot of the rail. So, if it is head, web or foot, accordingly a code is going to be used. So, what it says, if it is within the rail head, it is 1. If it is in the surface of the rail head, then it is 2, that means here. Then if it is in the web, 3, and if it is in the foot, 4. So, that is the coding being used here. The third digit, it defines the direction of the crack, and we are not going to give you the complete these 10 digits and their information. It basically defines that in which particular direction the crack is moving. So, it is moving towards the down, it is moving towards the up, it is going along the connection of the rail head and the web. So, different directions can be there and these directions can be defined by 0 to 9. So, that is the third digit, and if any other information is to be embedded, then there can be the fourth code, which usually may not be there, but if it is required, then something can be given as a code and can be added here. So, we may have first three as we have seen previously, say for example, we have taken OFS. So, it can be OFS with say 1, 3, 8. So, OFS 138 means it is a plain rail section which is being fractured due to the rolling stock, these three information, and the one is that it has happened in the fish plate area, and the 3 is that this is happening in the web area. So, this web area is there where the fish plate is being jointed, and 8 is the direction in which it is moving. So, that is how the overall code itself will give you the information. There is no need to write up all of these things in a detail. So, here the rail failures which may occur in different planes at a different locations, they have been shown. First of all, on the left hand side there is a rail section shown here, and with respect to this rail section, this is the vertical plane, we have the horizontal plane and then a transverse plane. So, that means the fracture which may occur can be in the vertical plane. So, I can say that there can be a fracture like this, or there can be a fracture in this form, or there can be a fracture on the rail head in this way. So, these rail fractures which are occurring, they are vertical plane, whereas in horizontal plane. So, there can be a fracture which is occurring on the head, say in this form, or in the web, or maybe in the section of the foot. And transverse, so the transverse is like just going in the other direction. So, these three are being taken there. Then otherwise, if you look at the right hand side diagram which is given here, what you can find is the transverse defects, they are occurring here. So, these are the transverse defects. Then in the head of the rail, if you see, this is on the surface. So, there is some surface defects which are occurring. Then there is a vertical crack which is going on in the web section. There is a hole for the placement of the fish bolt. So, what we found is that these cracks are coming out of it. So, it is termed as a star crack at the bolt holes. This is a diagonal crack which is occurring. There is a horizontal defects which occurs maybe like this, and the same things may occur here also, or at this particular portion or at this portion. So, therefore, there are different ways in which these cracks may occur, propagate, and finally may cause the total failure of the rail. So, you need to then in that case go for a complete renewal. Now, here we are going to look at these cracks which are also being defined in terms of the different categories. Say here in the category A, we are talking about the vertical cracks. So, if you can see that there is a vertical crack which has occurred in the rail head in this form, and then it is going here along the surface in the head of the rail. So, this is a vertical crack through the crown at the rail head. This can be one such category and is being coded as A1. See, another one is a vertical crack on the running face. So, the running face means this is the running face and it is going inside. So, if I talk in this form, so this will be going inside. So, this is a vertical, it is going to split the rail into two portions if it finally goes up to the rail end, or if it starts moving in the transverse direction, then it may cause the chipping or the removal of the section which happens in this way, that there is this particular transverse and this transverse. So, it will take out the total this particular section. It all depends in which direction finally the crack is going to propagate. Here we look at the another one. This is a horizontal crack, and this horizontal crack again is happening in the head. So, this is the way the horizontal crack is moving here. It can also be in the rail section as is shown here. So, this was as the rail end, and this is basically in the rail head, but not at the rail end, somewhere ahead of it. So, this can be another possibility. So, the previous one, this one, they are all in the head section. So, this is a crack in the head section which we are talking at the moment as a category A. Now, let us look at category B. Now, in the case of category B, we can see that there is a crack here being shown, and this crack at this location, this is at the junction of the head and the junction of the rail web. So, if we look at in this form, so it is occurring somewhere here. So, that is B1 being shown, and if you look at the crack in the body, so this crack in the body is moving here in this rail. So, it is away from the rail end, but then it can propagate maybe in the rail like this, or it can start coming towards the bolt. This is another one, category B, where the crack is at the junction of the flange and the web. So, this crack is occurring here, and if it persists and it further goes down in the vertical direction, then it will cause the removal of this flange area. It will break down, and that will bring in the condition that you have to replace further. This is again this is started from the rail end, but in the another case which you can look here, this is not starting from the rail end, rather it is within the flange area and is moving along the length of the rail. So, this is another type of failure which may occur. So, this can further propagate if this propagate in again in this form. So, this total portion here will chip off. So, you will have a portion in this form left at the flange. There is a category C. In the case of category C, it is a transverse crack at the rail head. So, you can see the transverse crack is occurring here. So, it is going all along the width of the rail head, and then it is coming down also. So, again, if such thing happens at two different locations, this will always create a possibility that this section of the rail head may again get break down, and if it goes into the form of, as we have seen in previously in the case of category B, that there is also a crack which starts occurring at the joint of the web and the joint of the rail head, then this total portion will break down. Here there is another case that a transverse crack is occurring now, as I said, that it may occur finally going to the this particular level and then coming down. So, it is like this happening, but not at the end. Basically, this is happening just away in the rail section. Then another one is occurring in the flange. If you see here, this is a flange area where it is happening, and then it is propagating to the bolt hole where the fish plate is going to be bolted. So, this is another issue, and finally, this bolt hole may get elongated, or the cracking may occur because of this. Here, though it has not propagated to the bolt hole, it is in the rail section only in the flange. So, this is only a crack has occurred here, but unless until this crack propagates in another direction or it comes at some other location also, then only the combination say of C and B, if it is there, may cause, say if it is happening in this form here at the joint of the web and the joint of the flange also, it occurs as a category B, and then there is a category C occurring like this. So, this portion will come out. There is a vertical crack at the rail end continuously in the rail itself. It is not being seen at the top, but you are seeing it from the side when it is being removed. Otherwise, once they are being jointed, it will not be visible, but otherwise if you go for a ultrasonic flaw detection here, so you will be able to find out if there is a crack which is occurring in the inner portions in the material of that rail. Here again there is a category D, which category D is starting from here, and in the web section again it is on the web going like this, whereas the another one is it is occurring somewhere here in the center where it is propagating towards the bolt holes. So, this is a total failure of the bolt hole will be occurring because of this reason, and in those cases maybe one solution can be that you have to crop the rail section, and whatever the rail section has been cropped, another new rail section has to be placed there and welded. This is a broken rail, as we were discussing, that if there is a transverse crack and there is a crack which propagates in the longitudinal direction in the rail head, then the combination of those two will cause a condition where the material will get chipped off from here. So, this is one such condition being shown, that is in the top surface of the rail head. Similarly, there can be a this type of a vertical cracking, and this vertical cracking along with the horizontal cracking going into the rail head at the rail end. If this persists in this form, so then this corner material will be broken and you will find a reduced section here. Then another one is that here not only the head has broken, but it has also taken away a certain portion of the web. So, probably there is a propagation in the case of the web, as we have seen as a D, and then there is a transverse propagation up and which has got moved to either of the direction, and then finally when the load has come at this portion, it has broken down. This is a case where it has happened above the bolt holes, but in the other case which you can see it is much more enlarged and it has taken up the total section here including the bolt holes. So, total big failure is there. Another E5, if you see, in the case of E5 nothing has happened to the head section. If you look from the top you will find that it is looking very good, but if you see from the side what has happened, the failure has started occurring in the flange area, and from there it has propagated to the web area, and finally this much portion this has broken down, it has got detached from it. So, now there is no support at this point. If there is a load comes at the rail head here, it is obviously going to just hog like this. So, and finally because no support is there and the loads are much more, then the breaking will also be occurring at this portion. Now, previously we were talking about the broken conditions in the rail head. Now, what we are seeing is in the flange area. So, here it is a combination of web and flange. So, those two are happening because there is a section of a web also which has broken down. In the other case, here it is only in the flange section and some flange area is still left. So, there is a, this is the joint and this is how the flange has gone down. Another case not happening on the rail end, it is happening along the rail section. You find that it is occurring there in this way. So, this material has got chipped out. Now, category G is also there. In the category G, what is happening is a total breakdown of a rail. So, at some position, so you can see that the rail has broken down here in two parts away from the location where the fish plate was placed. In another case, it has broken down, but at the same time there is a failure all along the bolts which are being punched in this rail section, because here the holes are there which are being punched, and on that the fish plates and the bolts will be placed. So, this total section has gone into a failure conditions. Here in this another case, what you found is that this is broken here, but then the failure is propagating in the opposite direction away from the rail end. So, if you see from this side, then you will find that everything is perfect, but if you go at this point or beyond, then there is a problem. So, these are a few of the other cases which can be there. Now, let us see some more things. Now, here there is a horizontal split. You found that the rail section at the top, it has got depressed like this. So, there is a failure which is occurring in the rail head. At the same time, there is a horizontal this crack which is occurring in the rail head. You can see from the side of the rail. So, there is an A and B, those two things are happening. And so, this is all basically in the rail head itself, but at the same time depression is there, maybe because of the heavy loads which have come, and the section could not sustain those in terms of its yield capacity, and then the plastic deformation might have taken place. Here in another case, horizontal web split is there. You can see that slowly if it keeps propagating, then it may split the whole of the web into two parts. Then here multiple things may be occurring. Say there is a crack which may be occurring at the interface of the web and the rail head. There is a depression here, the material is getting out. So, here there is a continuous crack which has occurred. So, number of things which are occurring here, and they can also be translated in the form of the various types of failure conditions which we have talked previously. Similarly, in the crushed head, here again the same condition as we have seen previously, that because of the loads, heavy loads more than 20 tons repeatedly coming at the location, and the rail section which is being used is 70 UTS. So, in those particular cases, this is a possibility which may occur. So, you found that the crack is here, as well as there are cracks coming in different forms at the same time. At the connection of the web with the rail head also a crack is propagating. So, this is another issue. Now, here we are talking about the fish bolt and hole cracks. So, in first case being shown here, what you found as this crack is propagating towards the rail head and is coming towards the connection, and there may be a possibility after some time this may start moving along the connectivity of the rail head with the web. In another case, it has moved towards the rail head, but at the same time it is also moving towards the rail end. And finally, if there is a problem in the case of a rail head, there is a transverse this type of a crack which occurs, then this whole section will be get chipped off after some time. Here again you can see that this crack which is continuously going. Along with that, there are cracks which are going in this vertical direction, and this crack has then finally come to the flange, and the whole flange is getting cracked. So, there is a possibility, one of the diagram we have seen that though the rail head is good, but this portion has chipped off. So, there is no support being left, and that is where when no support is there and the loads will come at the top of this particular rail here, it will cause hogging of the rail. Different type of transverse cracks being shown at this location. So, this is also another possibility which may occur. Now, let us talk about some of the specific rail failures here. The first one which we are talking is the wheel burn and then the scabbing. Now, when these wheel slips occur usually on an adverse gradient, we usually talk about a ruling gradient at some angle theta. So, this is defined as a ruling gradient. When we will take up the geometrics, then we will be talking about this, but say if it is being provided at a level which is higher at an angle of phi, where phi is greater than theta, then those gradients are steeper and there are issues in terms of the movement of the trains and the pressure which is being exerted by the wheels on the rails. So, in this case usually on the adverse gradients or while starting on rising gradients, the train has stopped. The station which has been provided, that has been provided on a gradient, and now it starts. So, there is going to be very heavy pressure at the back, and when considerable heat is generated, the top of the rail is torn off in patches, causing depressions known as wheel burns, from which the cracks may start developing. So, here at this particular position, because it is in a brake condition and now you are getting acceleration here, So, lot of pressure is going to be generated, and you will find that there is a rise in the temperature at this particular location, and because of this rise in the temperature there will be the burning of the rail head, and this burning of the rail head initially it will be going in this form if there is a plastic deformation which is happening, and then finally it may culminate into the cracks which may start propagating in different directions. This also occurs when the train brakes are applied. Under this train brakes, these are applied suddenly, or the wheel locks and it starts sliding. So, both of the cases, and specifically this happens when you talk about the railways which have been provided in the mountains. So, you go to Nilgiri railways, if you are traveling to Ooty by train or you are coming from Ooty to down by train, then in that case you will find this type of an issue. There will be abrupt and sudden applications of the brakes because the train is coming down on a steeper gradient. At some of the locations the gradients are quite steep there. So, as to control the speed of the train, then continuously they keep applying the brakes, and when they keep applying the brakes they have the brakes which are also being provided in the wagon. So, there are a number of persons who are standing, one person one wagon along with the driver in the locomotive. So, locomotive also it is applying the brake, as well as the wagons are also trying to apply the brakes so that the speed can be controlled. And because of so much application of the brakes on the head of the rail, the heat is generated, and that heat will cause a problem. The another condition can be that the locomotive which has been used in these cases, this is not having adequate power, and therefore a lot of pressure is coming, and because of that underpowering and lot of pressure which is getting exerted, these wheel burns may occur. These wheel burns cause the wheels to hammer the rails and lead to difficulties in keeping the sleepers packed firmly and fastenings tight. So, there are two problems which may happen, because the load which is coming in terms of the brake applications at any of the location like this. So, this is a big impact, and this impact can be in terms of a hammering impact on the rails. And when this hammering impact is there again and again on this rail section because of the number of trains which may be passing through, then the sleepers which are provided at the bottom here, or the aggregates which are being packed here, so as to sustain or keep the sleepers in position, all of these things will start loosening. So, and the connectivities of the rails will also get hampered. Here if they are being done with the help of the fish plates, then they will also start loosening. So, there is difficulty in keeping everything intact in position in the tightened condition. So, here you can see that what type of situation may occur to the rail head when these type of distresses are coming. The other thing is the rail scabbing. This occurs due to the skidding because of the inappropriate brake application. So, you have applied the brakes, the train should have stopped, but the train has not stopped, it has moved a bit farther, and that is where the skidding comes into picture. The slipping could have been that if the wheel has been moving more. So, here because of this skidding, when the brakes are not being applied to the complete force whatever was required to stop the train or reduce the speed of the train, then this rail scabbing is one type of a failure which may occur. Wheel burns can also occur due to the slippage of the locomotive wheels because of the inadequate power. We talked about that previously also, and the scabbing of the wheel burns eventually results in the sudden fracture of the rail due to repeated heavy impact loadings. So, these impact loadings which are coming in terms of effect of the braking or the starting up of a train on a section on gradient. So, all of these cases, these impacts are coming and they may cause scabbing and wheel burning. So, you can see that how the top surface may look like in the case of a rail that it has been burned. So, all these patches you can see that it is patches of the burning here, and the scabbing condition is also being defined on the other side. Now, let us talk about the rail plastic deformation. Now, this rail plastic deformation, this is a plastic deformation of the rail material. We did talk about it under the loads, we did talk about it under the pressures which are being exerted. So, it is the same here. The applied wheel or the rail contact stresses, they exceed the yield strength of the steel in compression. If this happens, then there is a possibility of the plastic deformation. So, at the top of the rail head, the load is coming here and the load is high in terms of the stress being induced in the rail section, and we have the strength parameter of the rail steel. So, the combination of this or a pressure being exerted, the compressive pressure versus the yield strength is what is being talked about. Now, this gross plastic deformation of rail occurring in uncontrolled manner leads to mushrooming of rail head and the surface corrugations. These are the two things which may happen. When we were discussing about the corrugations, at that time we talked about this plastic deformation, and then after the train has moved away, we said that the rail hardens and finally the corrugations remains in this form. So, there is a flow of the material because the load has come here. So, it has gone into the plastic condition, and as the wheel moves, so it takes the material in front in the forward direction, and that is how the waves will get created. Now, what is mushrooming of the rail head? Let us look at that. The gross plastic flow of the rail steel is usually observed under higher normal axle load more than 20 tons. So, this we have discussed previously that these type of the things are going to happen when 20 tons or more than 20 tons loads are being applied here. Now, plastic flow of rail metal on gauge side and or the field side of the rail occurs in the form of mushrooming of rail head. So, if you see here, there is a material which you can very distinctly see here different, and then the section of the rail head or side here. Here it is coming down also and then going up. So, that sort of a growth which is occurring because of the plastic flow. Now, this leads to tightening of the gauge, which may lead to the higher wear and excessive lateral hunting of wheel set at higher operational speed in the mild curves and the tangent tracks. Because now what has happened is the material, if we talk about this as a rail head, some of the material from the surface has moved and now it has come here. So, the surface has gone in this form, whereas the material has got deposited here. Now, when we talk about the another rail head here on the other side, this was the gauge 1676 mm, the broad gauge. But now, because this material has got deposited at this location on the gauge face, what is happening is the gauge has become not G, it has become equals to G dash, which is less than G. So, it means the tightening of the gauge is happening here. And because this tightening of the gauge has happened, if on the top of it there is a wheel which is moving like this, now the clearance which was available to the wheel to move in the lateral direction has reduced, and because of that there will be excessive lateral hunting of that wheel on the gauge side of the track, and these are the things may further increase in the case of the curves or in the case of the tangent tracks. So, this is a problem. So, we can stop here and we will be continuing with the rest of the type of the failures in the next lecture. Till then, thank you and bye.